Hello everyone, welcome to the stream. Uh, from last few days, I'm starting my stream very late of machine learning and deep learning. Uh, so I was setting up my system. It took me a lot of time. It's easy when you have like two desktops, so it is easy to manage the stream. But when I stream only on using laptop while standing. So at that time, like it's very hard for me to manage, and my system RAM is only 8 GB, so it's also like my system performance is a bit slower than earlier. I tried cleaning up, but it didn't work as such. In the end, I need to upgrade my system a bit. Sure. Uh, since I started streaming, I'm speaking in only English, very little Hindi, but I'm excited to speak in my mother tongue. So yesterday I was learning about this thing, uh, like how we can implement this neural network using TensorFlow. All right. So I'm going to reduce the speed to normal so that I can easily get the knowledge that I want. Okay, so let me share my screen with you all. So yesterday we did like pre-processing. We did data spread, then we also scaled the features. So after scaling the features, we have this X-train and X-test. So this is the data. So we are trying to train our model in order to predict this whether the person will exit the bank or not. So now I'm going to uh, start with this building the artificial neural network. So we are using TensorFlow. Here we import the TensorFlow as TF, and after that TF.keras. From the videos, I came to know like the keras was like earlier it was a separate module, but now they combined it with the TensorFlow itself, and basically it is API. We are just sending the queries and getting the results. I'm wondering like what would be the backend code of this. Okay, so I was studying about this. Let me open TensorFlow errors documentation. We are using this 2.16.1 version, I guess. Okay, so we are using 2.17.0. Let me see if I can change the version. Yes, this one is stable 2.70. So this is the module PF not chaos. Okay, so it has audio module, photograph, video is compact, a lot of modules are there. So we need this errors. Mhm. In this documentation, they just copy pasted, uh, I guess using the AI model. This file was automated, do not edit it by hand, since your modification will be overwritten. That's interesting. So they are using AI for creating these documentations. So I was using sequential, very sequential. Where it is a sequential class, sequential group, a linear type of pair into a model. Okay, so here it is. So sequential network model is type of neural network model in Keras, a high-level API for building and training neural network in TensorFlow, where there's a stack on top of each other in a linear sequence. Each layer has a single input and output, meaning that data flow network. The first layer to the last one in straight line of branching. Okay, so it is layer by layer, and that's the sequential. No branching is there. Simple and intuitive, straightforward network. So it means like we can easily calculate it. Uh, Order matters. The order in which you add the layer is important because each layer takes the output of the previous one as its input. Okay, so Like we are using multiple layers, so it is going to add one layer after the other, and it will be using the output of one layer to as the input of another layer, and it's a sequential, so it is doing like a sequence, not with a parallel execution. Suitable for simple networks, sequential models are ideal for simple architecture such as fully connected network or CNN and RNN. Okay, so I will get back to you once I study this topic. Now I'm going to switch to more. So this is what's going on so far. Like currently it is training. So here we added our input layers, adding the input layer and the first hidden layer. I guess this already includes the input layer and this is also the hidden layer. I don't totally get it, but the thing that I get it like there are six neurons in this layer, and the activation function we are using is rel. And once the input is passed through this layer, and whatever the output is, we will get by applying this activation function. So that output is going to be passed to our next layer. We can add multiple layers if we want to test uh, by changing the hyperparameters or by increasing the hidden layers. We can check if whether we are getting our accuracy good or not. So here we are just using two layers, and then there is output layer. In output layer, we are using only one neuron because in this data set, we only need this. We want to check whether the person will exit from the bank or not. Like a person will close his account from the bank or not. So there are only two possibilities, 0 and 1, and we can uh, get it using the sigmoid function. So sigmoid activation function gives us the output from 0 uh, and 1. I guess it was the same, I guess, sigmoid range. So it is like a sine curve, not sine, like S curve. Sigmoid function range. It's there 0 to 1. Yes, it's between 0 and 1. The system is lagging a lot. I'm training on the same system and doing every other thing. And after that, we compiled these layers. We are using Atom Optimizer. I need to study about this and binary cross and chopping. I also don't know about this. And the accuracy metrics we are using here. There are other matrices. Metrics like we can use the root mean square error and other things. Mean square error. So here it is. It is training. So uh, it's 56. It's training very slowly on this laptop, and the data is also not huge. So here it is. Here is what is going on. So the first report we received 72% accuracy, and the loss like the difference between actual versus predicted was 0.6. So it should be less. The lesser is like uh, we will get like more accuracy if the loss function is less. Like the difference between actual versus uh, that one predicted. T expensive. Hello, hello. And in second time we got like 0.4 loss function and 80% accuracy, then 79, it again decreasing, increasing 81. So it start from 0.6. So here is like very less 0.3. The difference. I guess we will get the output accuracy around 87. However, like we didn't done any other thing like removing the outliers. By removing the outliers, I guess it can be improved. Okay, so this is the first time that I'm running this deep neural network. So now it is like repeating 3.3, 3.4, 0.34, 3334. So it's repeating. I think we can stop this at around like uh, 53, 60, 70 layers. Yes, you joined in some other stream also. Too expensive. You joined. So how are you? For last few days, I'm sleeping late night because of which, like, uh, my sleep is bit disturbed, and now I'm feeling sleepy. So today I'm not going to stream for a long time. So I will just complete this and then wrap it up. Okay, so here we are getting some improved results 0.32. It means we can't assume as it is. So from this, I'm guessing like it is terrible idea to run these deep learning models on my system. And one more thing is like I'm using TensorFlow CPU. I'm not using CUDA cores. I guess that is the main issue. So I also need to configure that. If we check this, this is steady, 56% utilization. If we check the process, Google Chrome, it is using 0.7% CPU. Okay, so 15% CPU is used by this Prism Studio, the software that I'm using to stream, and this is working on an efficiency mode, which means it is not using resources to its full potential. The Chrome tab. What happened? When did it stop? What is the meaning of this 235 by 235? Does that mean like we are using 6 and 6 layers here? Sorry, neurons. 6 neurons are here in this layer and 6 neurons are here. And they are interlinked with each other. So that means 6 raised power 6, I guess, operations. No. Number of batches processed in stat approach. But we specify the batches 32 is melting. Yes, batch height is 32. Number of batches is equal to total samples divided by batch size. Okay, total samples are 235. First doing digital data point on instance for your dataset. For example, if you are working with the dataset of one customer, sample could be on customer's data. Example, credit score, age, balance, etc. In an image dataset, each sample would be a single image. In your document training, the element of a sample is a single row or entry in your training data. Okay, corresponding to one data point with its features. Mm. 455 samples in 32 batch. Can you give me the proper calculation based on below data? I had 10,000 records with how many features we have. that we used. Uh, we didn't use repository. We used only credit score, geography, gender, age, group, club, conscious, no, those in the 10 columns, and I used uh, the size 0.25%, 0.25% size. And two layers with six neuron, six generate of neuron, each having ReLU activation function plus 32 batch size and output layer I use single neuron in sigmoid function. Still running. So now it is taking a lot of time and it's consistent value 56. Let's see what the people will give us. I guess the system is going to crash. What is happening? That's what I was talking about. I guess my screen crashed in between. Oh, is it working? It's currently live. Okay. Oh, so we saw big dip here. It means I guess the process not strong. No, nothing's wrong. Something is wrong. This is stuck. Is it running? Yes, running. Okay, so let's see what GPT gave us. Let's bring down the calculation. Total count 10,000. Test bring 0.25%. Yes. Yes. This is two hidden lens with neuron railway equation function. Output layer with the single neurons in function. Batch size 32 means your data will be processed in 32 batch at a time. Sample. Okay, 32 sample at a time. Now to calculate how many batches will be processed in each epoch. Number of batch per epoch. So total training sample. Okay, so sample is 7,500 our training data. So training data is our total samples means we passed 7,500 rows to the system, and the batch size is 32, which is equivalent to 235. Okay, so from here we got this 235, which means that like it divided our training data set into 32 parts, and in each part we have no 32 parts. Batch size is 32. Okay, it created the batches of 32. In each batch, like there are 32. I'm not getting this is approximately 235 to 35 batches per epoch. It means like 235 samples are being given to the neuron. You have 7,500 training sample with a batch size of 32. You will process 235 batches per epoch. It means like this is the neuron, like with two layers, two hidden layers and one output layer. We have only three layers, and on this side, it means like 235 samples are in queue, and in single sample there are 32 records, and those 32 records are getting passed. And the single epoch mean passing, but this is a feed forward network now. Does this mean like 235? So all those 235 in queue are getting passed through the network one by one, and they will be passed 100 times. Okay, now we need to understand epoch. Explain me epoch. What happened? Okay, so this is not going to work anymore. In the end, we got 86, 87% accuracy. An epoch in machine learning refers to one complete pass through the entire training data set during the training process of model. Here's a breakdown of concept. Does this mean like all 705,000, sorry, 7,500 are getting passed through the network? Okay, so one epoch mean like our data set, the full data set is passed through the network. So that is like one epoch. During training, the model learns from the data. Each epoch involves the model processing the entire training data set, adjust its weight and bias based on the error of its prediction. Okay, so we are passing it to the network, and like here we received this value, accuracy and loss, and we have to minimize this loss. So in starting it was 0.66112, and then it is again passed to the network, and the weights are adjusted automatically, and then we save this output. And this is 235. So it is basically 235 into 32. It is basically that 7,500. So it means, so in single epoch, like our whole data set is passed. And this was the accuracy after passing the whole data set single time. And then it again back propagated to the network. But somewhere I read like we are using feed forward network, like this sequential. I read about this thing. This is feed forward, then how it is back propagating. Like here it is written. It is best suited for feed forward network where each layer directly feed into the next layer. So like we have two layers. So one layer is passing to the next layer. That is feed forward. Is the feed forward feed backward is different than back propagation? Multiple epoch training a model typically require multiple epochs. Each epoch allows the model to learn and refine its parameter further. The idea is that by going through the data multiple times, the model can learn patterns and improve its performance. Batch processing, the training data is often divided into smaller subsets called batches instead of processing the entire dataset at once. But what is the point behind this? Sending the data in batch. Why can't we just send the whole data? If we are sending in batch, this means we are calculating those weighted sum square, like we multiply weight with the input and then take summation. The model process once batch defined. After processing the batch, the model updates its parameter based on the loss computed for that batch. These continue until all batches in the epoch are processed. In feed-forward process, the input data is passed through the neural network layer in forward direction from input layer to the output. Each layer of neuron computes its output based on input it received and its attribution function. The process starts at the input layer, flows through all hidden layers, and finally reaches the output layer where the network makes prediction. The goal of feed-forward is to calculate the predicted output of the network for the given input. No learning or parameter update happen when this process happens. That means just passing through the network runtime. In neural network, predicting whether a customer will leave bank, the input features like age, balance, etc. are passed forward through the layers of neuron to produce an output. Okay, feedback code refers to the process of passing the error information from the output layer backward through the network toward the input layer. Backpropagation is a specific algorithm used during feed backward process to update the weight in neural network. Okay, so in feed forward, the input is passed, so the network and output is calculated. Backpropagation, the error is propagated backward through the network using the chain rule of calculus. So propagation computes the gradient, particular derivatives of the loss function with respect to each weight in the network. It determines how much each weight should be adjusted to reduce the loss in the next iteration. It means, okay, so once these gradients are calculated, an optimization algorithm like gradient descent to use. Hmm, it means we are using that backpropagation algorithm here, and here we are using Adam optimizer to optimize it. I need to study this in depth. Otherwise, there is no point to implement. Okay, let me watch a video of this further. When I started this stream, I was hoping like will we tend to sleep, go to sleep, don't do live stream today. And now, okay, let's watch the video. So I'm going to stop this so it is not going further. And it's 25 we watch from this onward. I'm not going to use this anymore. Jupyter Notebook. I will start doing this in collab. And let me watch video from my friend's channel, Digital Girl. Hmm. You need to study gradient descent, stochastic gradient, random optimizer, and other things. Okay, let me turn off red display. Oh, sticky note. Back application. Optimizer. After implementing, now I got lot of question, but when I was watching the video, like I thought I understood the concept, but I was wrong. In order to understand it step by step, so I need to decode it and go get deeper. Thank God I studied this topic earlier. Activation functions. I have some idea about this thing. All right. So that's all for today. So I will be continuing tomorrow. I need to get some good sleep today. So if anyone is watching, you want to chat for a few minutes, you can. Today I spent only an hour. So no one is here. All right. Uh, you guys. So, thanks for joining. Thanks for joining, everyone. So, this is the end of the stream. I will see you tomorrow. Goodbye. Good night.